Hello everyone. Today we will going to see some practice questions from the topic physical and chemical equilibrium, and this is our part 5. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Index slide which says that we will cover some practice questions from question number 33 to question number 41. Let's start with the question number 33. The following reactions are known to occur in the body, which is CO2 plus H2 giving us H2CO3 and which is dissociating into H positive and HCO3 negative. If the CO2 escapes from the system, what will happen? Options are pH will decreases, hydrogen ion concentration will diminish, H2CO3 concentration will be altered, the forward reaction will be promoted. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so our correct answer is option B, that is hydrogen ion concentration will diminish. So if CO2 escapes, if you see the system, if CO2 escapes, so reactant side is CO2. So CO2 is at reactant side. So if CO2 escapes, the equilibrium will shift at the backward direction, right? Because reactant will be missing. So equilibrium will shift at the backward direction, and so that H positive will diminish. Its concentration will be decreased. It will diminish. And thus our correct option is B, that is hydrogen ion concentration will diminish. Okay. Let's move to next question. Question number 34. Consider the following equilibrium in a closed container. This is the equilibrium N2O4 giving us 2 molecules of NO2. At a fixed temperature, the volume of the reaction container is halved. For this change, which of the following statements holds true regarding the equilibrium constant Kp and degree of dissociation alpha? We have to find out that which statement is correct one. If we consider that the volume of reaction container is getting halved and this is the reaction happening in the container, in a closed container at equilibrium. Options are neither Kp nor alpha changes, both Kp and alpha changes, Kp changes but alpha does not, Kp does not change but alpha changes. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So correct answer is our option D, that is Kp does not change but alpha changes. So Kp is constant at constant temperature because it only depends on the temperature. As volume is halved, it is mentioned in the question that volume of the container is halved. So as volume is halved, pressure will be double as they are indirectly related. Hence, equilibrium will shift in the backward direction. So when pressure get doubled, the equilibrium will shift in the backward direction, and that means that the degree of dissociation decreases. So K will not change, Kp will not change, but alpha changes. So thus our D option is the correct answer. Okay, let's move to next question, question number 35. The equilibrium constant for the reaction H2 plus I2 giving us 2 Hi molecule is 64. If the volume of container is reduced to half of original volume, the value of equilibrium constant will be. Options are 16, 32, 64 or 128. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option C, that is 64. So we have given this oh, sorry. Okay, we have given this reaction in the question, that is H2 plus I2 giving us two molecules of HI. And for this reaction, if we calculate del Ng is the moles of product in the gaseous states minus moles of reactant in the gaseous state. So it will be 2 minus 1 plus 1. So 1 plus 1 will become 2. So 2 minus 2 is 0. So for this reaction, we have del Ng is equals to 0. Therefore, the reaction and its equilibrium constant is not affected by change in the volume. And moreover, we know that equilibrium constant depends only on temperature, hence it will not change, right? So the reaction and its equilibrium constant will not affected by the change in volume, because the equilibrium constant depends only on the temperature and temperature is same. Hence our option C is correct, that is 64. That is the initial or given value for equilibrium constant in the question also. So it will remain same, that is 64. Okay, thus our option C is correct one. Okay, moving to next question, question number 36. The exothermic formation of ClF3 is represented by the equation this. Cl2 plus 3F2 will give you 2ClF3. And the formation of reaction del HR is equals to enthalpy of formation is minus 329 kilojoule. Which of the following will increase the quantity of ClF3 in an equilibrium mixture of Cl2, F2 and ClF3? So we have to tell that which thing from the options will increase the quantity of ClF3 at the product side in this equation at the equilibrium. Okay, so options are adding F2, increasing the volume of the container, removing Cl2, increasing the temperature. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see what will be the answer. So the correct answer is option A, that is adding F2. So reaction, you can see del H is negative. So reaction is exothermic. And by Le-Chatelier's principle, we know that the reaction is spontaneous in the forward direction, in the direction of formation of more ClF3, right? Forward direction means the product will be more, the formation of product will be more. And if F2 is added, temperature is lowered and ClF3 is removed, the reaction is spontaneous in the forward direction. So basically, we have asked in the question that which option from the options, which condition will increase the quantity of ClF3. So it is given that the reaction is exothermic. So if we add by Le-Chatelier's principle, if F2 is added, in the reactant side and the temperature is lowered, and ClF3 is removed and we remove ClF3, then the reaction is spontaneous in the forward direction. Hence our option A, that is adding F2, is the correct answer. Okay, moving on to question number 37. Consider the reaction equilibrium. This is the reaction. 2SO2 plus O2 will give you 2SO3. Del H is also negative, minus 198 kilojoule. Now, on the basis of Le-Chatelier's principle, the condition favorable for the forward reaction is. So, if we want a reaction to be forward, which condition will be favorable? Options are lowering of temperature as well as pressure, increasing of temperature as well as pressure, lowering the temperature and increasing the pressure, or any value of the temperature and pressure. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so let's see. So correct answer is option C, that is lowering the temperature and increasing the pressure. You can see this is the reaction given in the question. Del H is negative for this reaction. So del Ng, if you calculate 2 minus 2 plus 1, that is 3. So 2 minus 3 is minus 1. So you can see that del Ng is negative. reaction taking place with decrease in number of moles or pressure, and hence increase in pressure shifts the equilibrium in the forward side. This is the reaction happening. So the LNG is negative in this reaction. So this reaction is taking place with decrease in number of moles or pressure, right? So if we increase the pressure, it will shift the equilibrium in the forward side. You can also see that del H is negative for this reaction. That means reaction taking place with evolution of heat or increase in temperature, right? And hence decrease in temperature will shift the equilibrium in the forward side. And thus our C option, that is lowering the temperature and increasing the pressure, is the correct one. Okay, let's move to next question. Question number 38. In the following questions, assertion A followed by reason R is given. Choose the correct option out of the choices given below. So assertion is, in the dissociation of PCl5 at constant pressure and temperature, addition of helium at equilibrium increases the dissociation of PCl5. Reason, helium removes Cl2 from the field of action. So we have to choose the correct answer. Options are both A and R are true, and R is true explanation of A. Both A and R are true, but R is not true explanation of A. A is true, but R is false, or both A and R are false. So you have 10 seconds to solve the question. After that, we will see what will be the answer. Okay, so as you can see that our correct answer is option C, that is A is true, but R is false. So A is true. In the dissociation of PCl5 at constant pressure and temperature, addition of helium at equilibrium increase the dissociation of PCl5. This is the dissociation reaction for PCl5, giving us PCl3 and Cl2 gas. So the addition of inert gas helium at constant pressure and temperature results in increase the dissociation of PCl5. So the reaction will follow, or reaction will move towards the forward reaction in accordance with Le-Chatelier's principle, right? So addition of helium at equilibrium increase the dissociation of PCl5. This is correct. But helium removes Cl2. On adding helium, the Cl2 will be removed from the field of action. This is not true. And thus our option C, that is A is true, but R is false, is the correct one. Okay, moving on to our next question, question number 39. Again, we have given assertion and followed by reason. We have to choose the correct option. So assertion is, the reaction this 2NO plus O2 will give you 2NO2 is favored in the forward direction with the increase of pressure. Reason, the reaction is exothermic. Options are both A and R are true, and R is true explanation of A. Both A and R are true, but R is not true explanation of A. A is true, but R is false. Both A and R are false. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B, that is both A and R are true, but R is not the true explanation of A. So with the increase of pressure, equilibrium shifts in that direction in which lesser number of gaseous molecules are produced. So the assertion, that is the reaction this is favored in the forward direction with the increase of pressure, is true, and the reaction is exothermic. So this reaction is exothermic. This is also true, but R is not the correct or true explanation of the assertion given. And thus our option B, that is both A and R are true, but R is not true explanation of A, is the correct answer. Okay, let's move to next question. Question number 40. Assertion, the equilibrium constant for a reaction having positive del H naught increases with increase of temperature. Reason, the temperature dependence of equilibrium constant is related to del S naught and del H naught for a reaction. Options are Both A and R are true, and R is the true explanation of A. Both A and R are true, but R is not the true explanation of A. A is true, but R is false. Both A and R are false. So you have to choose the correct options. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option A. That is both A and R are true, and R is the true explanation of A. So the increased temperature always shifts the equilibrium towards endothermic reaction, and the equilibrium constant for a reaction having positive del H naught, that is for endothermic reaction, increases with the increase of temperature. Yeah, it is true because the equilibrium constant depends on the temperature. So if temperature will increase, equilibrium constant will increase. And reason the temperature dependence of the equilibrium constant is related to del S naught and del H naught for the reaction. This is also true. So both A and R are true, and R is true explanation of A. Hence our correct option is option A. Okay. Let's move to question number 41. Assertion: Haber's synthesis of NH3 is carried out in the presence of a catalyst. Reason: the catalyst shifts the position of the equilibrium of reaction to the product site. The reaction is N2 plus 3H2 giving us 2NH3. Options are both A and R are true, and R is true explanation of A. Both A and R are true, but R is not true explanation of A. A is true, but R is false, or both A and R are false. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so let's see. So the correct answer is option C, that is A is true, but R is false. So catalyst does not affect equilibrium. It increases the rate of chemical reactions, but by providing a new low energy pathway for the forward and reverse reactions by exactly the same amount, but it will not affect the equilibrium. So Haber synthesis of NH3 is carried out in the presence of catalyst. This is true. The catalyst shifts the position of equilibrium for reaction to the product side. This is wrong. And hence, our correct option is option C, which states A is true, but R is false. Okay, so C option is the correct one for this question. Okay, thank you.